All right, we've been talking about multiplication of radicals, the FOIL, distributed property, the special products, that type of thing. We've talked about division of radicals, but we want to focus now on division of radicals that have two terms. So something like this that has two terms. Remember, terms are separated by a plus or minus. So when we look at these, we want to look and see if first it has two terms, and then if one or both of these has a radical. If you go through and you say, well, it's got a radical in the denominator, you're thinking of rule 3, that is the reason why we can't have that radical in the denominator, why we can't leave it in this manner. So if you thought about, well, maybe you could simplify it using rule 1, quotient rule of radicals, that type of thing, or even maybe we can evaluate it. If it was the square root of 4, we could make it a rational value. When it has the two terms, if I go through, or if you maybe you had to rationalize it, if you go through and say, well, if I want to get rid of the square root of 8, any of those things that I just mentioned, maybe you can try to do that. You're going to get to a point where we need a process to take care of that rule 3. Right now we've got a radical in the denominator. We can't leave it like that, okay, and say it's simplified. So if we have two terms, I can't just go through and multiply by, say, the square root of 8 over the square root of 8, that rationalization factor we did with rationalizing the denominator. Because, yes, it'll take care of this. Square root of 8 times square root of 8 would be a perfect square. But this 2 is not inside a radical, so 2 times the square root of 8 would just be 2 root 8. I'd still have that radical. So what I need is a process. Now, if you haven't done this yet, the extra credit, test extra credit videos, you're going to go back through it and look at those. They're due tonight at midnight. They'll give you some background knowledge for this. If you don't choose to do that, at least you are prepared for this. In there we saw a process where if we multiplied something, the radicals would drop out. So what we need is that process. Well, that process was the multiplication of difference of squares. Well, the multiplication of difference of squares came from the multiplication of the conjugates. So if I have two-term denominator and one or both has a radical, what I need to do as my rationalization factor, I need to multiply this bottom by its conjugate. So remember, that was keep the first term the same, keep the second term the same, and change the sign. So if that's a positive, that's a negative. Now if I ask you what the conjugate of this was, it's this. Okay? But this rationalization factor that we multiply by here, whatever I multiply the bottom by, I don't want to change the value of this. I multiply the top by that same value. Okay? Now the top is got to be 4 times top times top. So we're going to need a set of parentheses. The bottom you can FOIL, but there's also that difference in squares shortcut we showed you. So if I go through and multiply this out, 4 times the square root of 8, I get 4 root 8, distribute 4 times negative 2. If you do not put that parentheses, you're only going to multiply the two closest things. Now, I can use the difference of squares shortcut. I can say this is my A, this is my B. So A squared minus B squared is the shortcut, or I could FOIL that out. Just remember, the two middle terms will drop out. A squared, square root of 8, quantity squared, minus 2 quantity squared. Power matches index, we just take out the base, we get 8 minus 2 squared is 4. 8 minus 4 is 4. That's my denominator. Okay? That can become 1, depending on these numbers. Well, when we look at this, we want to make sure we're simplified. There's a perfect square in 8. So in 8, I've got 2 squared times 2. I can take a 2 out. Because I'm taking that 2 out, I multiply to that 4. So I have 8 root 2. Oops, not plus minus 16 over 4. So we wanted to simplify that. We could have done that back here as well. It would change what we would multiply by here. Now we want to simplify, make sure we're simplified. So what I look to do is, in the terms, I look to see if there's a common factor with the denominator. Or I can split it up and do the division. So if I split that up, I get 8 root 2 over 4 minus 16 over 4. 8 is divisible by 4 2 times, so I get 2 root 2 16 divided by 4 is 4. And it simplifies. If it doesn't have a common factor in both of them, you can choose to split it up and reduce where you can. Just remember, we want to make sure that this is a lowest common denominator. Okay, so that just happens that there was a common factor. But if that was 15, I wouldn't be able to do that. Yes, I could still split it up and reduce that, but that would be 15/4. Sometimes it will be best to leave it in that, as long as it's reduced. And as we progress, you're going to start seeing answers start taking on this common form. Okay, you could even factor that out if there's still a common factor here in 2. Could leave it in factored form. Okay. The next video clip, what we will do is we'll work out another one. It'll be a little more involved. So the first thing I want you to do is recognize that you have a denominator that has 2 terms, that has one or both have a radical. Think of what is the conjugate to be multiplied, and we'll go through that process.